people still have this vision of telepathy, of transferring thoughts directly from your head. People who are in the neurotech space proper are pretty concerned about brain data. They have a fully active brain. Everything's great upstairs, but because some connection has been severed, their brain can't talk to the rest of their body. Because you want to know, what does it mean? What does it mean if my brain is showing these alpha waves? Wearing earbuds, and you can hear faintly a little bit of what's going on in the brain. If you tell somebody, hey, you slept really bad last night, actually you could make it worse, because now I'm stressed out about how poor my sleep is. Many years ago, I was like, hey, maybe I could do like writing at a neurotech company. But at that stage, the field wasn't really ready for me. Science journalism was a good path for me because it allowed me to interact with a lot of science and stay on top of what was going on. If you want to explore, or if you feel like there's a lot of different things that you're good at or you want to grow, startups can be really great for that.
Welcome, Dr. Caitlin Shure. I am so excited about our conversation today. How are you feeling?
I'm feeling great. Thanks so much for asking me to come on and chat.
You are based in New York, correct?
So I'm actually based in Mountain View, California right now. So I was in New York. I am a New Yorker to the bone, but I happen to be living in Silicon Valley right now. So a bit of a culture shock, but yeah, lots of things happening here.
Absolutely. So I know you are in Silicon Valley, it's the hub of technology, and you come from a science background. There's just a lot of technology and advances happening in the field of science. I feel there's a lot more integration of technology into science. So we'll talk more about that, what all this means to people, where the opportunities lie, because the more I read about all this, I feel like, is it even real? Like, is that even possible? It just sounds like science fiction to me.
Yeah. Yeah. And to be honest with you, to this more, but it's not always, the line between what's science fiction and what's reality is not always clear. You see a lot of technologies of today actually first being imagined like 100 years ago. And even though it's not like people are sitting around saying, what novels from the 19th can we copy? But these things get into the cultural imagination, and it's bi-directional, right? So you have the glimpses of an early technology that could be something as primitive as the telegraph, but that changes how people imagine what is possible. And then you get science fiction based on that. Then you get, to your audience, a new generation of scientists growing up with these ideas sort of in the culture. So there is a lot of interplay between sort of pretend and imagined realities and then the technologies that people ultimately create.
I love that. So we are going to really start at the basics. So I want a real sort of an explanation of what exactly is neurotechnology, just the basics.
Yeah. So neurotechnology, if you take apart the word, you have neuro, that's related to the nervous system. And mostly people think about the brain, but it's not limited to the brain. So that's the neuro part, and technology is technology. So it's really any technology that somehow is we typically say directly interacting with the. On the one hand, that seems like a very basic definition, but it's actually not so basic, because as you start to dig into it, there's a lot of gray lines. So even if we take something like the nervous system, or are we just counting as neurotechnology things that are interacting with the brain? Or do we count the rest of the central nervous system? Do you think about the spinal cord? Or do we think about the peripheral nervous system? So the peripheral nervous system is your nerves that are outside, or your neurons that are outside of the brain. You have motor neurons in your arms, your legs. So are we thinking about, do those count as the nervous system? And then it's also a little bit vague on the technology side and the interaction side. So are we only counting technology that's literally touching a piece of your biology, a piece of metal that's on your brain? Or do we count it as something that's on the other side of the skull? Or there are lots of kind of proxies for what's going on in the nervous system. So something that measures your sweat output is a measure of what's going on in your sympathetic nervous system. Even something like your heart rate. And so that's like, you don't think about your Apple Watch necessarily as a neurotechnology, but you are getting an indirect metric of what's going on in your nervous system. So it's actually really not clear. And on the one hand, kind of it can be sort of a semantic question, but it does become relevant once we get into the privacy space. If we think about having special protections for data that's representative of things going on in your nervous system, well, we all kind of have an implicit sense that there is something special about that data, especially if it's coming directly from the brain. Where to draw that line is not exactly clear. So even something like eye tracking software, which is not touching you directly, it's not the brain directly, it's your eyes, but micro like saccades of your eyes can tell you something about what's going on in your brain. So it gets very hairy. I would say, like, for practical purposes, or for people, people who are thinking about it as a field, then I default back to the very simple definition, which is technologies that interact with the brain. And then it's like, okay, because then in terms of a specialization or something, it's like, hey, do you like brains, or do you have a background in brains? Do you like technology? This may be a field for you. So I think for some practical purposes, there's a very simple definition, but then there are applications where you have to kind of open up that world of gray and get more nuanced about it.
And I think as we evolve, as the technologies evolve and it becomes more mainstream, it becomes more of a global question and everybody's involved. And then there are clearer definitions and demarcations on what constitutes what. I think one of the most public ways people know and think about it is recently Elon Musk, who needs no introduction, has a company called Neuralink, and the company makes brain implants. And they recently, I think it was a month ago, they live streamed their first patient who was a complete quadriplegic, and this person was paralyzed from the neck down, and they had received Neuralink's brain implant, and they live streamed on X that this patient was actually able to play chess on a computer, even though they could not move any of their limbs. Can you explain what was going on here and how is it different than the work you are involved in?
Sure. Very different than the work I'm involved in. So I would say, for starters, if you think about always the hero use case for medical neurotechnology or brain-computer interfaces, which is another slightly more specific term, people always talk about folks who have some form of paralysis, either no movement from the neck down, or maybe just no movement from the waist down. The most severe cases are so-called blocked in people who really effectively have no motor control of their body. And what's going on in those patients is there's some disconnect between the brain and the rest of their body. So they have a fully active brain, everything's great upstairs, but because some connection has been severed, their brain can't talk to the rest of their body. And that leaves them with the inability not just to move, but to even talk or communicate. So it's a very severe, devastating condition. So the goal of a lot of invasive neurotechnologies, and invasive basically means it requires some kind of surgery. You need to crack open the skull and put something underneath the skull to use it. The goal of a lot of the current projects in invasive neurotechnology is to reestablish that connection. So, okay, maybe my brain can no longer, because of some injury to the spinal cord, it can no longer directly tell my arm to move, but I can use the technology to gather that signal at the brain, and then that chip can communicate with a computer. And then from the computer, you can play chess, or maybe if the computer in theory is attached to a prosthetic limb, the computer can control that limb. So it's reestablishing that connection. How that's different from what I'm working on is, I would say, for starters, I'm not working right now in invasive neurotechnology. So you get the best signal by directly making contact with the brain, because you're right there. You can hear what's going on in the brain a little bit more precisely. There's less noise, and then you therefore get a greater quality of signal, and you can do more with it. And that's really what you need to have the kind of fidelity that these patients would be looking for. But obviously, it's a pretty big deal to get surgery on your skull. So at least at this stage, nobody's going to be volunteering for this kind of surgery unless there's a very dire need, or you're just like an extreme Elon Musk fanboy. Though I wouldn't advise somebody getting a hole in their skull just because they like Elon Musk. So what I'm working on is in the non-invasive space, which essentially means putting an electrode, so something that can sense electrical activity, on the outside of the skull. And the benefits of that is that, it's very low risk. It's basically no risk. It's as simple as wearing a headphone, or in the case of our product, wearing earbuds, and you can hear faintly a little bit of what's going on in the brain. Now, these are going to be nowhere near as precise as the kind of signal that you get from putting something on the brain directly, but you have different applications for it. Then you therefore sort of filter what you try to do based on what's possible at this date from a non-invasive tech. And then you can offer these in a more consumer setting. You don't necessarily have to be FDA approved depending on what your claims are. It's just a lot lower risk.
Asking you the same question that you started in your thesis abstract. What, if anything, is a brain wave?
Yeah, you'd think I would know after spending a couple of years of my life on this question, but I'll give a little bit of context for the question. So I previously had a career as a science journalist, and as such, was very attentive to the way people talked about the brain. And I would see this term brainwave. And though I kind of knew that people were talking about something having to do with electroencephalography, the electrical changes in the brain, they also seem to be talking about brain waves in this almost, to our earlier point, sci-fi sense of telepathy and, something truly emanating out of the skull. So I was trying to figure out, where did this term come from? What is a brainwave? And essentially, there are two sort of things that a brainwave can be. One is a mark on a graph. So if I'm measuring electrical fluctuations in my brain from an electrode, you will see rising and falling voltages. And that's like these waves. It looks like a wave, but what I'm really talking about when I say the wave, I'm talking about how it looks on a graph. So that's a thing on a graph, not a wave out there in the ethos. There's another definition of brainwave that is this more telepathic connotation that is, and this isn't real, this is an imagined thing, a wave emanating from your head that carries thoughts, that maybe it literally comes out of my head and then somehow goes into your head, and then you know what I'm thinking. Now, sitting here, you and I know that that's not real. That's not a real phenomenon that happens. But if you go back to, and this is what I did in my research to figure out where did this term brainwave come from, it actually comes from that connotation. The first time that term is used is in the 18th, and it's from a guy trying to explain telepathy. And he thinks, well, like there's some sort of movement going on in my brain, and this thought reverberates out from my brain, and it goes into your skull and gets into your brain. And that's how telepathy works. So I think what I've really discovered is that over the course of history is that these two connotations, this one very strict technical scientific definition and this more fanciful telepathic science fiction-y connotation, they've become kind of conflated, and people have sort of confused and combined them. And now we're at the point where the fantasy is almost informing the reality, meaning people are still have this vision of telepathy, of transferring thoughts directly from your head, and they're trying to build technologies that make that a reality. So even though telepathic brainwaves aren't real, it is sort of informing sort of at the aspirations of some technologists.
It was the gist of it. So when you talk about EEG, it is electroencephalogram. They are devices or electrodes that sit on your brain. They don't go in, they are on top of your brain. But do they fall under the umbrella of a BCI or a brain computer interface? They still fall under that?
Yeah, they can.
Okay. And so today, as somebody who works in consumer technology, are all of them basically EEG based devices?
Most of them are EEG based devices. There are theoretically other ways of doing it. Like people are exploring, there's this like functional near infrared spectroscopy. That's like another kind of light based technique that's also non-invasive, but it's at least at this point in time pretty big and clunky. So it could be a really interesting research tool, but probably isn't consumer ready yet. It would require kind of like a big helmet on your head, but I don't know, maybe it could be part of like a VR headset in the future. So because EEG, basically all you need is small electrodes on your skull built into something. It's really easy to put into a consumer product. So people have put it in helmets. People have tried it even in sunglasses. We're doing it in earbuds. Headbands is a really common path for it. So it helps I'll go back to super basics and explain how EEG works. So basically, when your neurons are active, when they're firing, that involves a change in electrical voltage. So your neurons are polarized, they become depolarized, ions move, but basically a charge change is happening. And when many neurons fire at the same time, so from outside the skull, you are not going to be able to sense one neuron firing. But when a lot of neurons fire at the same time, like big populations, even from outside the skull, you can detect that big change. And something about the brain is that is how the brain works. There are these, stereotyped kind of wave patterns of many neurons firing at the same time in sort of classic ways. There's certain states, particularly in sleep, we know there are different sort of speeds of waves or frequencies during different phases of sleep. All of these neurons are firing at the same time in a rhythmic pattern. So EEG is really good at detecting those kind of changes, as versus if you're on top of the cortex, on top of the surface of the brain, you can detect smaller populations or more specific dynamics. And if you're piercing the surface of the cortex, you can get even more targeted measurements. So that's what's going on in EEG, is basically from the outside of the skull, those electrodes are able to sense big population dynamics.
What is the use case of knowing this information? How are these scientists' neurotechnologies being translated into consumer products and devices? And how are they helping people?
Yeah, so I think the best way to I'll start with, people have tried to do many things with consumer EEG with varying degrees of success, but kind of to the point about from the outside of the skull, you can only sense certain dynamics, sort of very big dynamics. So that has by definition sort of limited the possible use cases. One of the things that EEG is really good at detecting is alpha waves. So it's literally the first thing that was detected back in between 1905 and 1920 when EEG was first invented, are these alpha waves, a very stereotyped pattern. And alpha has been attributed to, because you want to know, what does it mean? What does it mean if my brain is showing these alpha waves? And it can mean a couple things. Some people, it has been associated with tranquility and sort of like this Zen-like state, or it can be drowsiness. So it's sort of this, and it increases when your eyes close. So people have interpreted this different ways over the years, but because it does seem to correlate with people sort of successfully meditating or achieving a more relaxed state. Back as early as the 70s, there were these like alpha wave biofeedback monitors that were basically telling you when you have reached this alpha state, so that if you meditate with the device on and you get the feedback to say, hey, you've achieved alpha, maybe you'll get better at meditating quicker. And it's funny because that's this application that has been around for half a century, but people are still building new products based on the basic premise of alpha feedback. So I think that's a big class of applications in the consumer space that's been around for a while. And then another that people have tried to achieve, again, if we're thinking about what are broad brain states, people have tried to look at focus. Can we see if the brain is better focused? I think it's a little bit more controversial as to whether that's, focus detection is valid at this stage, but that's something that people have used. And I should add that in a lot of these cases, it's all functioning off of this premise of biofeedback. Like if I can tell you when you've achieved a certain kind of brain state, you can get better at achieving that brain state. And then sort of segueing into what we're working on is another application is sleep. So EEG, since it was used since the very beginning of its application clinically, has always been good at detecting sleep stages, because again, sleep is very stereotyped. It follows a predictable pattern. When you're in this like light sleep, your sleep looks like this. When you're in deep sleep, it looks like this. When you're drowsy, it looks like this. So EEG is really, really good at measuring sleep. And that's what it's been used for in a clinical setting for diagnosing and treating sleep disorders. And what we're working on is bringing EEG sleep staging to the consumer setting. And the reason that has not really been done before, or hasn't been done so successfully before, is that it's required a lot of miniaturization of the technology. And it's also required required kind of user proofing of it. So you can do it in a lab because you have a person, the technician that's putting it on you and making sure the electrodes are connected well, getting a good signal. But it's also a little bit clunky, which is why like some sleep studies, some argue data from sleep studies isn't that realistic because you're not at all in a setting that's representative of how you sleep. And also, you kind of have to foolproof it. So a lot of the work that we've done and some other folks have worked on this problem as well is figuring out how to make it really small, really comfortable, and then create a user experience that makes it kind of foolproof. But that doesn't necessarily, I say all that to say we can measure sleep and our device does that, but why, right? What am I doing? And I think there's one approach to take that I think some others are taking, which is via EEG, we can create the best sleep tracker ever. So sleep trackers, whether the Oura Ring, Apple Watch, Fitbit, Garmin, they're different wearables, have seen some solid traction with user adoption of sleep trackers in the past 5 years, with the hypothesis being that if you know how your sleep is then you will intervene to make your sleep better. There's also some pushback against this concept because some people feel like, well, people who have bad sleep already kind of know that their sleep is bad. Or even if you tell somebody, hey, you slept really bad last night, actually you could make it worse because now I'm stressed out about how poor my sleep is. It's sort of like a self-fulfilling prophecy. I feel bad because somebody said my sleep was bad. And now I'm more stressed out before I go to bed and then I don't fall asleep as quickly. So with EEG, we do have this amazing sleep tracker, but we are also very sensitive to how we're using this data. So what we have philosophically landed on, we don't want to use data just for data's sake. We want to use it to actively improve sleep. And because our form factor is inside the ear, we put EEG inside an earbud. We are using your brain state and therefore your sleep stage to adjust your audio experience. So maybe you like to listen to Harry Potter to fall asleep. You listen to an audiobook. So the earbuds will have this audio that helps you fall asleep. And then once we detect that you're asleep, we can switch that to maybe a more like a white noise sound or a noise masking sound that helps you stay asleep. And then once you are in a deeper sleep stage, we can have a tailored sound that's supportive of helping deepen your sleep and helping you wake up, feel more restored. So whereas just tracking wouldn't do anything, it would just tell you data about all your different sleep stages. Here, we're trying to use that information in real time to support a better sleep experience.
So, is it fair to say that you are actually trying to achieve the alpha wave state in the brain? You're actually trying to modify. Is that possible to do it with these devices? Can you actually alter or get the brain into that state so you can get into sleep?
Yeah. So for sleep, you wouldn't necessarily be doing, you could. So if alpha is linked to feeling like calm and relaxed, then yeah. And it's not for alpha feedback. It's not exactly like the device is doing it. So there's some approaches that's like, oh, maybe we'll try to stimulate your brain with like either electrical stimulation or some other kind of stimulation, like auditory stimulation or visual stimulation to sort of like snap your brain into a certain kind of phase. And that has been explored for sure. But with more conventional alpha feedback, it's more like you're doing the work, you're doing your normal meditation routine, whatever it is. And you'll get some sort of cue, like maybe a sound plays when you've hit it. And then so you learn what works for you for getting to that state.
So you're essentially training your brain over time to understand those cues and move into that state. That's fascinating. So are these devices right now that's on the market, what all do they cater to? Is it only for sleep or are there others on the market that's available for consumers to use?
Yeah. So, different devices sort of cater to different audiences. There's a few that are targeting more of that focus space, either for cognitive applications, like knowledge workers. I've also seen certainly in the elite athlete space of getting you really in the zone before the game or whatever. And so that's like the focus contingent. There's also definitely that meditation application is still a big one. And then there's the sleep application is another.
Are there any devices that have made claims that they can sort of help with psychiatric disorders or just mental health challenges like ADHD or depression or anything like that? Is there any devices on the market with those claims?
Seen any specific devices around depression necessarily. There are certainly some that slip into the attention ADHD, and that's where it becomes sort of like a regulatory, you're kind of walking a line because you can say this device helps you focus without going through the FDA, but once you make a claim around ADHD, then it becomes more specifically linked to an actual disorder. There is what you will see a lot is like neurofeedback practices in a clinical setting. So maybe a therapist or psychiatrist might incorporate a device into their practice. And then you're kind of like under the care of a professional who has some sort of regimen around some kind of biofeedback training for a particular disease. I'm sure there are devices that are specifically catered for those types of applications, but I don't know what they are off the top of my head.
So what's on the horizon? Like what are the most promising technologies and promising devices that are out there, like people in the field are waiting for or excited about?
Well, I obviously think the most exciting and promising ones is the one that I'm working on. But
of course,
I will say, I think more generally, there are a couple things related to my product, but not specific to my product that I think will define the future. One is to improve the wearability and practicality of it. So for decades and decades, people have been trying to put this thing into headbands, and the headbands have been getting smaller. The headbands have been getting cuter, but they're still kind of goofy looking headbands. And as we know, with any technology, widespread adoption is contingent on it being socially acceptable. And, if you want to get beyond just like that early adopter biohacker crowd. And as we do see more miniaturization as well as more on-device processing power, I think you will see these things integrated into a more acceptable form factor, such as the earbud that we're going after. And sort of relatedly, I think they also have to be integrated into the rest of our technological ecosystems a bit better. Existing tries at Neurotech, it's kind of its own practice, or it's like, you set aside this time to do your meditation training, or it's specifically marketed at people who are interested in brain technology or want to try out something experimental. And I think to make it work, you need to link it to a practical use case or link it to a technology. So if you think about, the Apple Watch, like with my Apple Watch, I get all sorts of long-term trends about my health, my movement. They try to do sleep. It's only so on accuracy, but it's really low cost for me to collect that data on myself because it's also a great watch, and I can use it to control my music, and I can use it to see my text messages. And so we don't necessarily think about the Apple Watch as like I'm biohacking or I'm doing a scientific experiment. It's a tech accessory. And so I think as we think about the next generation of neurotech, it's going to have to be way more integrated like that, both on the hardware side and the software side.
So seamless integration of these technologies into our daily lives is how the future would look like. What are you most concerned about in this space?
Yeah, so definitely concerned about data issues, data privacy, who is going to ultimately win this space. Big tech doesn't have a great track record with personal data. And once you get into the space of brain data, then it feels extremely sensitive. And I'm a little bit of two minds about this. On the one hand, if you look at what can be gleaned from EEG right now, you can't tell what you're thinking. Like it's not that specific. Like I said, going from outside the skull, the data isn't, you can only get these very broad kind of vague states. And especially compared to like looking at how I interact with my computer, you can tell way more about me by looking at my search history than from reading my EEG data. So I think the good side of that is because when you say brain data, people get like, it immediately is like, no, I don't want Facebook having that. Then I think it kind of makes people think more generally about their data and can be a good mechanism for prompting deep thought about your personal data. So I think that's good. But yeah, I am concerned. I think there are a lot of people, I would actually say most people who are in the neurotech space proper are pretty concerned about brain data. And even if they don't have their privacy policy fully nailed down and there's like room for improvement, at least philosophically, they believe people should own their own brain data. But if you look at the bigger tech companies, they're not necessarily coming from that background. They're coming from models that benefit them when people's lives become worse. sort of benefiting from the attention economy and not really caring how their technologies affect the well-being of people. So I think when we think about either how, a neurotech device becomes integrated with one of those tools, or if one of those companies acquires an existing neurotechnology, I think there's going to be some clashes there.
So do you think there will be a future where these types of technologies can actually capture so much information that they will have to be protected and the laws will have to be even more stringent about distribution?
Yeah, I think so. And I actually don't think it's kind of going back to where I started with the lines being blurred. I don't think it will just be the fact that, hey, maybe brain sensors are integrated into your glasses or your earbuds. I think it'll be that platforms now have your brain data, but they also have your heart rate, and they also have voice recognition software that kind of can tells your affect or your mood based on that. And there's eye tracking, and all those things combined, you absolutely can tell a lot about a person in terms of what's going inside their body, how they feel about things. So I think the good thing is, because neurotech is coming up, people are starting to get worried about this. There's, legislation has been introduced in a couple states to give special protections for brain data. But I do think that the conversation needs to be more encompassing, because we are going to find out that you can find out a lot without doing anything directly with the brain.
And again, thank you so much. This is I learned so much myself. There's so many things that I have not even read about. So this is very cool. So you come from a neuroscience behavior background. You moved into science journalism and then into communications. How did you find yourself where you are today? What was your career journey like? What were the pivotal moments that got you here?
Yeah, so, it definitely was not a linear trajectory. On the one hand, it seems pretty obvious in that I've always been, or at least since undergrad, I've been interested in neuroscience and brains, and I've always been kind of a techie, so it makes sense that I would be interested in neurotech. But it was absolutely not clear that I was going to end up here. I always thought that I wanted to do something with the brain in a lab. So it really just took a lot of trial and error to figure out what that looked like. Science journalism was a good path for me because it allowed me to interact with a lot of science and stay on top of what was going on and sort of pursue interests as they arose, and also fulfill the more humanities verbal side of me. But I don't know, I think I wanted to be closer to the action, which is why I started to lean more towards industry, but got into it in a very organic way. And that my first roles in the wearable industry were very much writing editorial roles. And, I still do communications and content in my current role. And so I really came to it that way. So my role before this, I was at Levels, which I think was a really one of those pivotal moments, in that Levels was a startup. It was my first time I was working in-house at a startup. I was doing essentially science journalism, but within a startup. And then from there, I got to also work on the product. Levels does glucose monitoring, so also wearable, but not in the neurotech space. And, through that experience, got to see what it felt to work on designing user experience, to interact more directly with consumers, stuff like that. So then when I came to NextSense, my current company, I was able to do both again, work on product and marketing. And I would say, in terms of, for people listening who are thinking about careers, if you want to explore, or if you feel like there's a lot of different things that you're good at, or you want to grow, startups can be really great for that. If you have the appetite for a startup is a very specific dynamic. It's not as, it's not as always organized as a more legacy company. You don't know what to expect. It's not for every temperament. But if you can tolerate that kind of dynamic, it's really great for growth, because at a startup, there's always more work than can be done. And so if you're like, hey, I want to try this, usually people will welcome the extra hand. And because the needs of a startup are always changing. Right now we're fundraising. Now we need to demonstrate pre-orders. Now we need to really do a marketing push. The people who do well at startups are the people that can grow into the roles as they emerge. And through that That's a really great for self-discovery and also for, showing on your resume, hey, I've done all these different things.
Whole range of experience, and it gives you an opportunity to figure out what is it that you're really interested in. So the whole field of neurotechnology, what are some of the most common educational backgrounds that you're seeing, or is it across the board of science and technology?
I think it's pretty across the board. There's obviously certain roles that are very specific. Like if you're going to be operate on people's skulls, that's like they're very strict requirements for who they let do that. But you can be, especially as the field grows, you can have any kind of background and kind of apply that to neurotech. I mean, I know when I first started many years ago, I was like, hey, maybe I could do like writing at a neurotech company. But at that stage, the field wasn't really ready for me because nothing was really consumer facing. Everything was incubating and like I couldn't really find a role. But now, as there's more companies, they're getting bigger. You need everybody. You need somebody to design websites. You need somebody to do marketing. And so I think you can break into the field from any background, though it might not be immediately.
So for the future, in terms of growth opportunities and seeing where the field is moving to, how would you sort of say what is the most promising growth in job opportunities that young professionals like, I better skill up in this area, or, I know coding is not all that, but there's still technologies out there. What are like some of the upcoming technologies that are finding, I may be hinting at AI, but is that really that important? Like, how is neurotechnology incorporating the latest into their
AI, machine learning, is definitely a piece of it. That's going to be, as we start to think about, especially with these non-invasive devices, people who are able to take that signal, that sort of like mess of brain data and extract something meaningful from it, or potentially combine multiple streams of data, let's say heart rate and brain data, and extract meaning. That is going to be a hugely valuable skill. And more generally, I think, computer science degrees are going to continue to be useful. But I would say, like, on top of that, something that I've really realized in my career is having that background plus something else, then you are like an all-star. So if you are even just like sort of a software developer generalist, but you're also really great at communicating, then I will pick you as my candidate 10 out of 10 times. Or even if you just show interest outside your very narrow engineering background. So I do think it is important for, like, probably everybody knows, yeah, if I want to do the technical sides of things, I have to get an engineering degree. Yes, of course you do. But I would strongly encourage folks to at least take some courses in writing and verbal communication, because when it comes down to it and you're actually working with people, being able to communicate your ideas is so, so important.
I also have heard the term skill stacking being used in this aspect, where you are really good at one, but you stack another skill, you become a little bit more attractive in the eyes of as a candidate. So this has been super valuable. Thank you so much, Caitlin, for joining us today. I'm so excited for this episode and can't wait for everybody to listen to it. Thank you.
Thank you so much. This was fun.
If you like this episode, please like, share, and subscribe, and comment below to let us know what other topics should we be talking about on this channel.